Energy can be transferred from one store into another. As one store empties, another store fills. The process by which this happens is called a pathway. There is one pathway that you are very familiar with in chemistry, called heating, due to temperature difference caused by a chemical reaction. But there is also another pathway that can happen, electrical work. Charges can move due to a potential difference as a result of a redox reaction. If you connect a strip of magnesium to a bulb and then connect that bulb to a strip of copper using two wires and no power supply or battery whatsoever, nothing happens. But if you then stand the two strips in a diluted solution of a salt, for example sodium chloride, something amazing happens. The bulb lights up. A current flows. Leave it for a little while longer, and what you find are that bubbles of hydrogen start to form on the copper strip, and the magnesium strip begins to dissolve into the solution. So what's going on? Well, magnesium is more reactive than copper in the reactivity series, so the magnesium atoms have a greater tendency to give up their outer shell electrons and go into solution as ions. Now, the electrons from the magnesium atoms flow along the wire to the copper strip as a current. Now, the solution contains sodium plus ions and chloride minus ions from the sodium chloride. It also contains some hydrogen plus ions and hydroxide OH minus ions from the water. Now, remembering our rules from electrolysis, hydrogen is less reactive than sodium, so the hydrogen plus ions accept electrons from the copper strip. So the magnesium is oxidized and the hydrogen ions are reduced. A redox reaction is causing the transfer of energy through the pathway of electrical work, charges moving due to a potential difference. The metal strips, the wire, and the beaker of solution in this example form a simple cell. A simple cell consists of two metals and an electrolyte. The more reactive metal is the negative pole of the cell, and electrons flow from it. So here, electrons flow from the magnesium strip, so it's the negative pole. The copper strip is the positive pole, and the solution of sodium chloride is the electrolyte. Now remember, in electrolysis, a current brings about a reaction, but in simple cells, reactions produce a current. You may have heard of a demonstration called the lemon battery. This consists of a lemon, an electrolyte which is the lemon juice, and two different metals that make up the electrodes connected with wires. You could connect a voltmeter into the circuit to measure the voltage. You could then connect an LED into the circuit and find out if there is any difference in the voltage. The bigger the difference in reactivity of the metals, the larger the voltage and the more brightly the LED will light. In the hydrogen fuel cell, hydrogen and oxygen combine without burning. It's a redox reaction, and the energy is transferred as an electric current. Like a simple cell, the fuel cell has a negative pole that gives out electrons and a positive pole that accepts them, and an electrolyte. Both poles are made of carbon. The negative pole is surrounded by hydrogen and the positive pole by oxygen, which is in the air. The electrolyte contains hydroxide OH- ions. Don't worry, you won't be asked to draw the fuel cell. This table shows the two half equations, and adding the two half equations gives the full equation for the redox reaction. So the overall reaction is that hydrogen and oxygen combine to form water. Now you may be asked the question, why does the concentration of the OH- hydroxide ions in the electrolyte not increase? Well, at the positive pole it's producing hydroxide ions, and at the negative pole it's quenching, it's using up hydroxide ions. So that's the reason why it doesn't change. A huge advantage of the hydrogen fuel cell is that only water is formed. There are no pollutants, and the reaction gives out plenty of energy. 1 kilogram of hydrogen gives about 2.5 times as much energy as 1 kilogram of natural gas, methane. We will not run out of hydrogen. It can be made by the electrolysis of water with a little added acid. Solar power could provide cheap electricity for this, and certain algae also produce hydrogen. Scientists have shown that it can be made from waste plant material using bacteria, but the huge drawback is that hydrogen is very flammable, so it must be stored safely. I do hope you've enjoyed this video, and I do wish you the best of luck with revising this. Just remember to look at the advantages and disadvantages of the hydrogen fuel cell. Try and come up with a table or bullet points and list the advantages and the drawbacks. Remember that hydrogen is very flammable and is also really tricky to store. Come up with the half equations that take place in the hydrogen fuel cell and maybe label a blank version of that diagram. Best wishes and best of luck.